Introduction to Neural Networks with C#, Class 11, Part 5. Welcome to Part 5. In this part, we're going to actually put the neural network that we've been building to predict the S&P 500 to the test. We're going to see how well it actually can predict with the S&P 500. We're going to run it against future values of the S&P 500. We'll see how it runs against these values that we had at the printing of the book, but we did not run the neural network against them. Just so that we could train the neural network properly and then validate it, we did not train the neural network with all of our data values. We saved some towards the end to act as future values to validate the neural network. This is very important for neural network programming. You don't want to train the neural network with every piece of data you have, then marvel at how well it predicts the data that it was already trained on. It needs to see how well these past values can actually predict future values. So keep some future values in reserve so that you can actually train the neural network and then evaluate it with these future values. We're going to now evaluate how well the neural network does with the S&P 500 data after it's been trained. We begin by looking at the output from the program. Here you can see the neural network operating on data that it was not trained on. This is data that occurs after the range of dates that was used for the training session. You can see for each date what the actual change was and what the predicted change was, as well as the difference. The difference is, for this range, usually just around a few percentage points. So it usually is predicting the actual direction of movement in the S&P 500. It's not quite so accurate on how much it's going to move. So you can see here some of the basic prediction techniques. This is not enough accuracy to actually use to drive a real investment strategy, and by no means a recommendation by me to do so. This is just educational purposes showing what the neural network in a very basic state can predict on the S&P 500. Now let's see how the prediction is actually done. Here you see the display function. This is what is used to implement the display of the prediction. It begins by creating a present variable that is going to hold the data that will be presented to the neural network. It's output size times 2 because we're passing in both the S&P 500 historical data as well as the prime interest rate. We have a predict array that is going to hold the prediction from the neural network and an actual output array that holds the actual output from the training data. We are using historic data that it was not trained on, so we do have the actual output, so we can evaluate how well it actually performed. Again, you do not want to use data that you actually trained on, or the neural network is going to simply predict what it was already trained with. We then loop across the samples and we only work with samples that are past the predict from. So we only want to look at samples that are later than the prediction date. Again, this keeps it from predicting based on what it was trained with. It's more interesting to see what the neural network can predict based on future values that it was not actually trained with. We then begin a string that is going to be output. We start with the word start equals, and that is going to let us know the date that it's giving us the date that we start with, and then we're saying the starting value. This comes from the actual data that we are going to be presenting to the neural network. We'll then begin by getting the input and the actual. Now that the data has been obtained, we call on the neural network to actually make its prediction. We assign this prediction into the predict array as returned from the compute outputs function of the neural network. We then display the actual and the predicted values. These are the percentage changes. We need to calculate the error between what the neural network predicted and what the actual output was. To do this, we are going to use the error calculation class. The error calculation class is the root mean square calculation class that we implemented earlier. This is the same error calculation class that is used by the training algorithms to determine how far off the anticipated from the actual values are when the neural network trains. This same class can be used just as well when we are evaluating the output from the neural network. This concludes class session 11. In this class session, you saw how the neural network that we created to predict the S&P 500 performed with actual S&P 500 data. You saw that it can predict some patterns in the S&P. However, it is definitely not investment grade. It is meant mainly as an introduction to financial forecasting with neural networks. In a real application, you may want to pick a single stock price instead of the entire S&P 500. You may want to use additional variables rather than just the historical prices for that stock. You may want to pick other companies that are related to that company in some way. This fundamentally comes down to how you're going to create financial programs with neural networks. You need to pick what inputs into the neural network you think will have some bearing on the future stock price of the company that you're trying to predict. This can be other stock prices, the prime interest rate, or other financial indicators provided for the companies that you are predicting. In this class session, there is a program assigned. This is Program 2. For more information about Program 2, visit the course website. Program 2 is due by Class 14. In Class 14, we will review my implementation for Program 2 and show you how I would have solved the problem. This concludes Class Session 11. Class Session 12 shows you a whole new type of neural network that we have not seen yet in this course. We are going to move on from the feed-forward neural network to something called the self-organizing map. The self-organizing map is a type of neural network that classifies. It takes input data and moves the input patterns into specific groups that you predefine. We will see an example of how to use this sort of neural network to recognize handwriting samples. It will take a handwriting sample and classify it into groups that correspond to the letters that it has been trained with. We hope you will continue with Class Session 12. Thank you. This course is based on our Introduction to Neural Network Programming books for Java and also Introduction to Neural Networks for C#. Available in both paperback and ebook format.